Brian, I got this funky light on, man. It's a red triangle with an exclamation point in the middle. That cannot be good.
That cannot be good. Usually you got disco balls and lights in your vehicles, but that's not right.
No, it's not right. And this is a zero emissions vehicle, so all new rules apply. Matter of fact, Brian, grab all your personal belongings and your little children by the hand, because when this leaf stops, the automatic doors are going to open up. Next stop, Tech Garage. Well, folks, today's show is going to be electrifying, and I mean that literally. We have a FEV, a full electric vehicle in the shop today. Welcome to Tech Garage, presented by rockauto.com.
I got to tell you, I'm convinced that in this Leaf we can get that LS engine, but that's probably another show, another day. This is interesting. The symptoms you've discussed and talked about are not the typical symptoms. So tell us what's going on here.
Yeah, exactly. Well, I was actually driving along and I got this light on here, man. And this is a new one for us here at Tech Garage. A little triangle there, red with an exclamation point in it. Scary, not your check engine light. Found out through the actual owner's manual.
Guys,
yeah.
This almost never happens. Usually he's the guy writing this stuff.
Had to break out the owner's manual. Red master warning light. That was scary. In here says a whole lot of nothing except take it to the dealer. So, you know, broke out the scan tool, figured I can handle it, no problem. Scanned it, a couple of multiple codes, some weird funky stuff going on. Couldn't figure it out. Every time I tried to get in, kept asking me to take it to the dealer. Well, broke down, wrote it over to our Miller Nissan down here, scanned it, come up with the codes, actually talking about some thermal meltdowns. Got a coolant fan problem. Coolant fan, interesting on an electric vehicle.
Absolutely. When you hear thermal and meltdown in the same sentence from a dealer, that's typically not good. And I've seen and used our scan tools. They're pretty good. It's an interesting trend, folks, that you can't harvest the code yourself with your backdoor, backyard scan tool anymore. You got to go to a dealer. So I'm glad you did. But like with any hybrid or electric vehicle, there's some real important safety procedures we've got to honor to get this thing ready to work on. I'm going to go get that going.
Yeah, you know, we're talking about high voltage, but more importantly, high amperage that will kill you. So yes, that cutoff is huge. Once you pull that, take about 20 minutes, let it dissipate. Meanwhile, I got some cool demos to kind of show you the evolution of what happened to hybrids to full electric. Our friends over in Canada from Console Lab actually sent us this cool demo right here on a board so I can show you how it works. Now, it all boils down to how the car is here. You have a motor here. We call this an ICE, internal combustion engine, and then you have these motor generators, 1 or 2 motor generators, and it's pretty simple, but we have to know what's a motor and what's a generator. So if you look right over here, I have a simple motor, a couple windings right here, and what I can do is I can hook it up here to positive and negative with a 6-volt source. I can actually show you the magnetism as it starts to spin and it goes around. So my electric motor takes off, and there it goes. Now what's happening, there's a term called counter-electromotive force. You remember those old generators? I think Brian's still got one on his car. It actually sends some voltage back up through the system, and that's our generator right here. It actually induces a voltage, and when I spin that, you can actually see it right there. We'll talk about regenerative braking here in a second. But let's come back to our board here, and this is pretty cool because there's different types. You can look at that first graph, and it talks about a series, and a series is just basically like our Leaf here. It's driven by that electric motor. The ICE motor is only used to charge the battery. So what I can do here is I can hold this ICE motor, and I can actually turn it. And if you listen, everything has to spin, and it's pretty difficult to turn because the electric motor is doing all the work. The ICE isn't helping whatsoever, and you can hear it spinning. I'm driving all the generators to the wheels. Now, if you go to the next graphic, that's a parallel. We're going to use the ICE, the internal combustion engine, and the actual motor generators to work. So I'm going to do that. I'm going to take them both, listen to the difference, and watch how easy it is. I can actually spin it. So my ICE motor is helping the actual motor generator. You see that on a lot of hybrids. And I'm going down the road and I'm powering it up. Now what happens with the third one is a series parallel. You get a splitter in the mix. You can use the ICE to charge the batteries, and the ICE can also help drive the wheels. So if I come over here and I drive them all, super easy. I got 2 motor generators running it and everything's going on. Now, you also have another thing called regenerative braking. This is our last graphic right here. If you look at the regenerative braking, I can come over here, I can hold the ICE motor, and what happens is when you start to slow down, you can see. You see it actually pulling? Now what am I doing? I'm actually pulling the actual generators, the motor generators, I'm reversing that polarity and I'm charging it. Well, how does that work? Well, come over here, I can show you. We can actually make electricity, which is really cool. I got the meter set up and I have a piece of wire right here. And this piece of wire, when I cut that magnetic field, I'm actually going to induce a voltage into it. And watch the meter, here I go. So as I go up and down, I'm actually inducing that voltage. Well, what's happening with the car? Well, the wheels are starting to slow down. We reverse the polarities. We actually start to make that motor into a generator, just like those old starters on the cars used to be, big old generators, counter electromotive force, backup charging the batteries. Right here, if I spin it, there it goes. I'm taking it, I'm recharging the system. Now on our Leaf, it's full electric. And what does that mean? Well, you can see it right here on the graphic. We have a power delivery module on the top with a DC charger, a DC-DC converter. We have the charging system up on top. Below that, we have an inverter, and on the bottom is the whole traction motor. Well, what's going on? Well, all that stuff creates heat. That's a problem. So we have a low pressure radiator system, about 130 degrees. That thing comes on, the pumps start cooling that system. If that doesn't cool, we have problems. Well, speaking of cool, Brian's running over there about as smooth as a 3800 Buick with a counterbalance shaft. We'll check in with him after break and see how it's coming along. Stick around. There's plenty more Tech Garage presented by rockauto.com.
Tech Garage, presented by RockAuto.com, is brought to you by Hunter Engineering, state-of-the-art wheel aligners and wheel alignment machines. Custom Auto Sound, the originator of classic car OEM fit radio since 1977. And by RockAuto.com, all the parts your car will ever need.
Well, welcome back to Tech Garage, brought to you by RockAuto.com. Well, one final mounting bolt in the top of the old cooling fan, but before we got to this, we pulled that master disconnect switch inside. Not hard to get to, 3 10mm bolts, a cover, pull the switch. We let more than a half hour go by, so all of the energy has dissipated. Then came up to the front, pulled the charging harnesses back in. Again, just a couple bolts in here. Nissan's made this access very easy. Pulled them back out of the way. No way they can jump in and get in the way of the project now. Now we're ready to roll. Now, if you're an avid Tech Garage viewer, and I know you are, you're asking the next natural question, which is, how do you know that you got to replace the fan? Well, keep in mind, this goes back to John's trip to the Nissan dealer. They scanned the code. Then they did a final output test of the fan to see if it was in fact working or not. It was not. We couldn't even do that test with a DVOM right here in the garage. That's how proprietary all of that circuitry is. So the problem is the cooling fans. Now, interestingly, both bolts are out. There's a couple connectors over here. I've got them loose. It sits down in a channel in the bottom. It'll lift out in a second. But while we're here, this is the coolant reservoir. Now, we talked about the thermal transfer heat properties. It's all the same as a traditional big system. But look at the coolant hoses. These are the small guys that look like heater hoses, and that's how it flows. This is up out of the way. You can get a good look at it, and I think John went to the rockauto.com shelf to get us a new cooling fan.
Yeah, Brian, I found 2 of your biggest fans, man, right here.
I'll take all I can get.
Well, actually, you actually got the module right here, which is super nice. From rockauto.com, the whole module. We're covering all our bases, make sure that we get everything fixed and fixed right. The whole fan assembly's right here, one piece. Matter of just pulling that one up out of there. Once you get it up out of there.
Looks like it's kind of wedged, so we're going to step it up out this way.
There you go.
Now, you always want to take care of the back of that radiator. If you're doing this by yourself, cardboard on the back of it, but there's no shame in our game. We've got a second set of hands. Let's get this guy in.
Yep, I got it plugged in already, Brian. A matter of just bringing it up and over.
Roll it down, back in the same way it came out.
Yep.
Watching that radiator.
Yep, we got these high voltage wires right here. Let's go a little bit on your side.
Yep, you got it. We're gonna roll your way.
All right.
Come on.
Pull these wires, there it goes.
Yep, a little more past that one wire. Good.
Whole module stuck there.
Keep coming down. I like the fact that we're nowhere near the radiator, so that's good. Yep. There we go.
Not so
perfect.
Easy. Yep. Good
2 10mm bolts. Sit that in the channel. That's good. Maybe a little dielectric gel in those connectors. It's down in the weather down there in the road grime. We'll get this thing buttoned back up. It's going to run like a champ.
Well, we got our LS all tore down and we're ready to make some precision measurements, and we'll do that right after the break. Stick around, there's plenty more Tech Garage brought to you by rockauto.com.
I just know that LS engine's going to fit in here. I just know it.
Well, welcome back to Tech Garage, presented by RockAuto.com. Well, it's time for the LS lesson, man. I'll tell you, Brian, we got this thing tore down. You got it cleaned up really nice, and the Honan cylinders, I got to tell you, they look pretty good, my man.
Wasn't hard to do. I tell you what, it went smoothly. We got a little bit cleaner in there. A couple other little tips of the trade here. We went through and took a die, a tap and die here, and went through every single threaded hole on the engine block to clean it out, rechase those threads to make sure there's nothing in there that's going to be a problem later on.
It seems like a simple thing, but Brian, you know, that's our torque specifications. We're only using about 10% clamping force on these bolts. You clean every one of them, you got a good torque, that's going to make the difference in the end.
Absolute game changer. Next thing we've got to do is we've got to check every single surface. Deck height, we got to check for anything being out of square. There's multiple checks you do here. We got the gauge, a feeler gauge, set up for 3/1000ths. We're looking for gaps here. Again, everything's got to marry up perfectly so we don't have any leaks, any compression issues. You want to check this way, same sort of thing. You check this way, same sort of thing. And ultimately, we're going to come back and we're going to do a couple more checks this way.
Absolutely.
We'll do it on both sides.
You can set that up. You can look at the first graphic there. I mean, there's all kinds of specifications out there, whether it's a service manual or a GM form. Find out what the specs are. Brian's just kind of using it as a go, no-go gauge. Well, what does that mean? We'll do that a lot. Basically, we're setting it up to the max. If it fits through there, you got a problem. Now, what's the problem? If it goes through there, you're going to have blow-by. That cylinder's not going to seal. You're going to have all kinds of issues with overheating, cooling problems, low compression. Not a good thing. Doesn't fit, you're good to go. If it fits, time to stop. Not going to work.
Looks pretty good over here, I must say. I'd like to do your side next, but we'll come back to that.
Yeah, you know, on my side, I'll start over here. I actually want to talk about cylinder bore, cylinder taper, the measurement. A couple measurements you can make and look at the cylinders not out around. That's pretty cool. Professionals, well, I got the cylinder bore gauge right here, which is pretty cool. Kind of taper. I can put it there. You can see it move up and down when I move it. Now I'm going to pop that in the cylinder. When I pop it in the cylinder, I'm simply just going to hold it across one side here, and I'm going to run it up and down. I'm reading the gauge. I'm looking for taper from the top to the bottom. You'll know. Then I can move it side to side, 90 degrees, and I can see if it's any out around. I'm looking at the numbers as it goes up and down. Old school method, well, you get an old telescopic gauge, man. These things are inexpensive. They just pop out like that. Put them in. You don't have to have these fancy tools. You can get it close. Look at the specifications once again. Use it as a go, no-go gauge. Pop it in there, make the measurement, take it out, take your micrometer, make the reading, okay? If it fits, wonderful. Now that I got it to the specification, put it back in. Top, bottom, left, right, up and down. Like Brian says, he's always looking for that perfection in there. Take the bottom, subtract it from the top, and then you'll know your taper, and side to side. Same thing, awesome measurement.
Absolutely, and I tell you what, if you've ever cleaned out a rifle or shotgun barrel, you've seen a brush that looks very similar to this. Now, I'm going through every single cooling passage, every oil passage, every threaded hole, and just making darn sure we've got nothing, no contamination in there, no grit or grime is left. We're looking pretty good over here, but this is a little bit methodical, takes a little bit of time. Just take your time and get this right. Clean the brush after every stroke. And I'm working all the way through. These are the cooling jackets right here. That's going to be critical because I think we're probably going to run this thing pretty hard.
You know, and some of you are saying, you know, Brian, that's a little nuts, man. We're getting crazy. No, we're not. This thing, that's the coolant passages that are going by the cylinder. If something's overheating there, well, you may have a lean condition. We talked all about that with engine performance. If I have a lean condition in one cylinder just because the coolant's not going through, that's a problem. Even more important, he's passing through the oil passages, man. There's no way for the oil to return or get to the different components in the engine without going through the oil galleries. Now, we highly recommend at this point, send it to machine shop, have them do all that, and you'll be good to go. You know, there's a couple measurements we can make down on the bottom as well.
Yeah, let's flip it over.
Let's do it,
Look
man.
here,
We'll go your way.
Yep, come around my way. That's good. Well done.
Nice, nice, nice.
Right.
Well, here's the main bore that goes straight through here. Another thing you want to make sure that main bore, we're going to make a lot more measurements. Stick with us. I know what you're thinking. There's taper, there's all kinds of stuff. Yes, but this main bore is important as well.
We're looking for alignment here.
Simple as that. Got your feeler gauge?
Yep. We're good. Going to check here. Good, good, good. I'm going to do both sides here. Good. Even though that's thin, it's only a 1/4 inch thick, you want to check both sides. You just get absolutely more accurate reading.
And think about that. Your crankshaft's not running true if this isn't true. I got the bearings. I'm going to wipe them out in a heartbeat. The bore has to be straight. I know it seems a little crazy. We're doing all these measurements, but this is what's going to make the difference, man. You sure want to join us next week. We'll take the piston and make those measurements as well. Hey, stick around. We're going to go over to Garage Ed, man. Got a cool segment for you there. We'll be back with more Tech Garage presented by RockAuto.com.
Tech Garage, presented by RockAuto.com, is brought to you by Clamp Tight, the clamp making tool. Steel Rubber Products, quality crafted rubber parts and weather stripping. And by RockAuto.com, all the parts your car will ever need.
Welcome back to Tech Garage, presented by RockAuto.com. Well, this week's Garage Ed is all about the cam sensor. And boy, let me tell you, the cam sensor has changed engine performance forever. More about that a little bit later. Let's actually look at the cam sensor. What is it? What does it do? Well, here it is. It's actually looking at the position of the cam. Why do we want to know the position of the cam? Well, we can tell exactly where it's firing, when it's firing, and what valves open at what time. That's pretty cool. And I could fire it up for you. Down here, you have the crank position sensor, and up here's the cam position sensor. You have a mechanical link with the timing chain that's going to run it. So when I fire it up, my crankshaft's down there. He's reading what's going on with the crank, where it's at, but more importantly, my cam sensor knows what cylinder's where and what valve is where by all these little indentations and teeth. It can be a Hall effect or it could be a magnetic sensor. We'll talk about that next week with crank position sensors. Now, what makes it such a game changer? Well, we can do misfire detection. That's pretty cool. My crankshaft is spinning around down here, and every time I get a pulse, boom, a fire, pulse, you get a little bit of a pickup there as it goes. Now, if it's picking up, and not picking up for a while, well, that's a slowdown in the crank. So what does the computer do? Looks up at the cam, says, hey, where are we? What cylinder? What's going on? Well, there's your PO 301s, 302s, 303s, exactly what's going on. Then it uses sequential fuel injection. We couldn't do that before either. We had to do multi-port injection. Now, if I know what cylinder needs the fire and the fuel, well, I can deliver it directly. That's the job of a cam sensor. And even better yet, variable valve timing, man, VVT. Here on our engine, you can see it right here. This is pretty cool. I can take the cam, I know the position of the cams, I can advance them and I can retard them, and I could look and see what's going on. And you can see it right here. I actually have the cam position sensor right here. If I pull this off, this is pretty cool. I'll set this over here, and then right here, the cam position sensor's looking down at these marks, so he knows exactly where this camshaft is. I could look at a V8, I could look at a 4-cylinder, I can look at 2 or 4 of them, but I know exactly where the cam position is. But you know what? It's not going to use all this cool technology if the cam sensor's not working. That's why Brian's checking one out.
Okay, with everything out of the way here, I'm removing one of the 2 camshaft position sensors. Essentially, what we're going to do is check the guts inside of it, the windings, the wiring, look for resistance, look for loss of signal and voltage inside the thing, which would mean something's broken inside and it's got to be replaced. Be careful with the harness. These crack. This is tough conditions up here. Just work the sensor up out gently, and I'll give you a good look inside here. There's 3 posts, 3 pins. You can see on the graphic here, we're going to test it 3 different ways. You're going to go pin 1 to pin 2. Look for infinity or 0. You're going to go from pin 1 to pin 3. Then you're going to do pin 2 to pin 3, and that ultimately will tell you the voltage you're sending inbound. Is it getting lost or is it coming back through? And that tells you the health of this really important sensor. What's it do? Well, you saw how it works. This is the great enabler. The computer needs to know where the valves are in relationship to the camshaft to know when to send spark and when to send that fuel charge. And these little guys have a big job in that equation. Well, for more tech tips, John and Tom got you covered.
Now, Tom, whether it's a cam position or a crank position sensor, you know that computer kicks a code. It'll say cam or crank. That doesn't mean the component's bad, does it?
No, you got to think about the problems that could affect any old car, the plumbing between the sensors and the computers, the wiring. At RockAuto.com, we have the connectors that all these things plug into. Under electrical connector, your crankshaft position sensor, that's something to check before you start replacing the part. Is go to that connector. It has a varmint chute on it. Has it corroded, started to separate away. It might be a $2 connector versus a $100 component that needs to be replaced.
Now, Tom, this is really neat about RockAuto.com. You have the view. This is neat for me because I'm looking actually the pin configuration. This is going to be just like factory. I look in there, I got the weather pack. Do you have some side views and different views I can look at?
Sure, you can blow it up. You can see it from different angles. Make sure it matches your connector, and you can see what is likely to fail if there's a little O-ring or something that's letting water get in and that corrodes the connectors, or expands things or something.
Yeah, there's a big term out there, CPA, and it's not a public accountant. It's Certified Position Assurance. Make sure that thing's connected well. Check them out on the web. I'm going to check out Brian. We're going to wrap things up.
We're all buttoned back up, everything's torqued to spec, everything's wired back up. You know, it's interesting, with all the technology on something like this, a full electric vehicle, heat still kills. So that thermal transfer, everything being repaired in there is critical to the life of the brains of this thing.
Brian, we went electric, buddy. It wasn't that big of a deal. Just make sure that you're using the safety precautions, make sure that that thing timed out. This thing will kill you. It could be dangerous, but that fan worked out great.
It certainly did, and we had a blast on the LS build today. Measurements, measurements, measurements. It was awesome.
Key to the build. Garage Ed, we talked about the crank sensor, how important that was. Brian, I'm thinking this one, maybe a cold air intake, some headers, exhaust.
Yeah.
Wrong show. Hey, we're out of time for today. Join us next week for more Tech Garage, brought to you by rockauto.com.
On the next Tech Garage, the team sets out to stop a bouncy SUV with a Magna-Ride system. Plus, John and Brian prepare to install the pistons on the LS1. And Garage Ed is all about crank sensors. See you then.